Hi! This is on indeterminate forms and application to L'Hopital rules. We're going to go over infinity over infinity, infinity times 0, and infinity minus infinity. So let's get started. Okay, so when we're dealing with these forms, there's one approach that I'm going to show you to it, and I'm going to go ahead and write down the form now. Okay, so that's going to say the limit as x approaches a of f of x over g of x equals the limit as x approaches a of f prime of x over g prime of x. So as you already know, f prime of x is the derivative of f of x, and the g prime of x is the derivative of g of x. So you probably went over it when you went over 0 over 0, but to review, it's taking the derivative of the numerator, which is going to be f of x, and taking the derivative of g of x, which is the denominator. So it might be confusing right now, so we're going to go over a couple examples so that it will make more sense. So let's go over an easy example first. Okay, so we're going to start off with infinity over infinity. So I put out an example right here, and as you can tell, the two functions both approach infinity. So if you plug in 1 for f of, we're going to call this f of x for now. Okay, so if you plug in 1, that equaled 8, and if you plug in 2, that equaled 10, and then as you keep on plugging in bigger and bigger numbers, it's going to approach infinity. And then it's going to be the same thing with 3x, the second function, which we're going to call g of x. And so you see right now that both of these functions approach infinity as you keep on plugging in bigger numbers. And since that's an indeterminate form, infinity over infinity, we're going to use the approach that I just wrote down. And so what we're going to do is take the derivative of each function. So I'm going to go ahead and do that now. So the derivative of f of x would be 2 over the derivative of 3x, which would be 3. And don't forget to put the limit okay, so you saw this one, and you can see that this one will approach 2/3, and by using L'Hopital's rule, you can take the derivative of the top function and the bottom function so that you can actually get a limit that would be approaching. Okay, so that last one was pretty easy, and obviously on the AP test, you probably won't get an easy one like that, so sometimes it's going to involve more steps to it, and so we're going to try a different example. And same thing as the last one, if you plug in greater and greater numbers into these two functions, they would both approach infinity. So we're going to go ahead and use L'Hopital's rule. So we're going to go ahead and take the derivative of this function right here, and it's going to be 10x minus 3 over this function down here. It's going to be 14x. Okay, so last time after we did one step, we already got the limit. But this time, as you can see, if you plug in more numbers, higher and higher numbers, this one, they're still approaching infinity. So what we have to do is take the derivative again. So we're going to have to use L'Hopital's rule one more time. The limit is x equals infinity. And the top function here, the derivative would be 10 over 14, which is the derivative down here. So now you can see that we finally approached a number that the function would approach to. So sometimes you'd have to use L'Hopital rules multiple times in order to get an answer. So that was the basic of working with the indeterminate form infinity over infinity. But a lot of the times you're also going to be working with trigonometric functions like tangent x, cosecant x, and other ones like that. So I definitely know them because they're going to come up. Like, for example, if they give you the limit as x approaches pi over 2 of secant x over 1 plus tangent x, would you know how to solve for that one instead of just the regular functions? So if you do know, then you can go ahead and skip on to infinity over infinity times 0. But if you don't, then I'll work it out too. So for this problem, we're going to tie in L'Hopital's rule. And for secant x, remember that in your trigonometric functions, the derivative of secant x is going to be secant x tangent x over the derivative of this bottom function, which is going to be secant squared x. So since this limit is approaching pi over 2, you can go ahead and just plug in pi over 2 into this equation, but that would be a lot more complicated, and what you can do is simplify it. So how I'm going to write it is 1 over cosine x times sine x over cosine x, multiplied by the reciprocal because it's dividing. So what I'm going to do is write the reciprocal of secant x squared, which is going to be cosine x squared. So what you know right here is since cosine x times cosine, oh, I'm sorry, I forgot the s. Since cosine x times cosine x is equal cosine squared of x, you can go ahead and cancel these out so that the limit as x approaches pi over 2 would just equal sine x. And from there you can just plug in pi over 2, and that's a lot more simpler than just plugging it into this equation right here. And then what you end up with is 1. Okay, so just be aware that sometimes like trigonometric functions will show up, and it's not just limited to like polynomial functions.